Hello, and on this video, we're going to take a look at the metric system in a little bit more depth. We're going to again take a look at the meter, gram, and liter, the base units for the metric system. But then we're going to also start to take a look at some of the prefixes that you can put in front of those base units to make them either larger or smaller. And today we're going to focus on the prefixes of kilo and milli. Then I'm going to introduce to you a method called the factor label method, and that is for converting back and forth between different units. It could be in the metric system or in any system. I've used the factor label method in physics, chemistry, biology, or any type of science where you have to do basically a word problem and solve for a word problem. It's very powerful. It helps you make sure that your units are always correct in your final answer. And if set up correctly, you always know when you're supposed to multiply or divide. You never make any mistakes like that. So the factor label method that we're going to be introduced to today is going to be used throughout many of the videos and talks that I do that deal with mathematics and chemistry. And then we'll close the lesson by doing some sample problems of converting from one of the base units, either meters, gram, or liter, and then converting using kilos or millis as prefixes. So again, this label is, or this video is labeled as a green or a basic video because it is pretty much a beginner video. There's not much pre-knowledge that you need to have. I did cover a video before this that looked at types of measurements, the systems that you can measure in, where you're looking at English or metric, and then what types of measurements you can make, either length, mass, or volume. And then it did give you a very basic introduction to the meter, gram, and liter. So if you feel a little bit lost in this video, then you can feel free to go back and look at the previous video, and I'll make sure I put a link up on the screen for the previous video so that if you want to go back and check that one out, you can. So let's get started with today's video. And one thing I want to do is I want to go back and take a look just briefly at just the base units for the metric system. Again, the meter, liter, and gram. And before we stick prefixes in front of them, like a killi or a milli, to make them either larger or smaller, let's just make sure we understand where did those base units come from and why are they the size that they are. So if we take a look first at length, the metric base unit for length is a meter. And if you remember in previous videos, I told you that a meter is about 3 feet long. And the reason I tell you that is so that if you're doing some type of a problem and you get an answer, you want to be able to kind of tell, is your answer right or wrong? If they ask you how long a baseball bat is and you come out that it's 7,000 meters long, that doesn't make any sense. It should be maybe, 1 or 1.5 meters long at the most. But how did they come up with this 3 feet? Why is a meter 3 feet? Well, it all started back in 1799 in France. France came up with the metric system, and they kind of standardized the lengths in it. And the way that you come up with a standard length is you have to use something or measure it against something that doesn't change. And what they used was the Earth. The size of the Earth doesn't change, it's consistent. So if this is a poorly drawn model of the Earth, and that's the equator there, what they did in France was they said they measured from the North Pole. So if that's the North Pole, if you measure from the North Pole and then you go all the way down to the equator, that distance from the North Pole to the equator, that's a long distance. You're looking at thousands of miles there. But they could measure that, and it was a consistent distance. You could measure it hundreds of times, and it would never change. So what they did was they took that distance and they divided it by 10,000. So, or 10 million, sorry. So this distance is the Earth's quadrant. And what that is basically it's a quarter of the way around the Earth. And if you take that distance and you divide it by 10 million, you get exactly 1 meter. So if you take the distance that it takes, the distance from the North Pole to the equator, and you divide that distance by 10 million, it comes out to about 3 feet or a meter. That's how they came up with the length that a meter would be. They used something that would not change, that they could measure over and over again, the distance from the Earth from the North Pole to the equator, and that's how they came up with this standard length of 1 meter. Well, if that's how they came up with the length of a meter, how did they come up with the standard metric unit for mass, a gram? Well, it's kind of interesting. Once they knew that they had a standard length, they used that standard length to help come up with a standard mass. And here's how they did it. They chose a length because now they could measure length very accurately because they had standards. And they took a cube, a hollowed out cube, that was 1 centimeter on each side. And then they took another substance that has standardized properties, water. Water has properties that are not going to change. They took water that was 4 degrees Celsius and they filled this cube with water. And they saw that if you filled a cube that was 1 centimeter on each side with water, that cube would weigh exactly 1 gram. So they used the size of the Earth to determine what number they would pick for the meter. And then they used this standardized length that they could measure now. They used a centimeter and another substance that has fixed properties, water, to determine the standard mass of 1 gram. Well, the third metric unit, the volume, the way that they figured that out was now they used this standard mass that they came up with. So for volume, the standard unit for volume is the liter. And the way that they came up with a liter was they just said, well, if you have 1 kilogram of water, so there's the mass that they had come up with previously, 1 kilogram of water. And they said, well, how much volume or how much space would 1 kilogram of water take up? Well, it would take up 1 liter. So if you take a look at, say, a 1 liter bottle of soda, which is mostly water with just some solute in it, it's going to weigh about 1 kilogram because 1 kilogram of water takes up 1 liter of space. So that's kind of how they came up with, the length for a meter, the mass that they use for a gram, and the volume that they use for a liter. But what we want to focus on today is taking a look at, well, what if we want to measure things or we want to make those base units larger or smaller? And we want to specifically look at two prefixes today for making these base units larger or smaller, and that's going to be the milli and the kilo. And the reason that I picked the milli and the kilo to start with is because these are some of the more common metric prefixes that are used. There's literally dozens of metric prefixes that make these base units larger or smaller, but especially in the milli and kilo are used a lot because if you're looking at one of my degrees is in organic chemistry, when they measure out medications, it's usually measured out in milligrams or thousandths of a gram. When you're looking at measuring mass of a person, if it's not in the United States, if it's in the United States, they measure it in pounds, but if it's not in the United States, they use kilograms or thousands of grams. And if you're looking at distance traveled between, say, cities or distance traveled between countries, they tend to use kilometers. So the kilo and the milli are very commonly used as converters to make the base units of a gram, a meter, or a liter either 1,000 times larger or 1,000 times smaller. So that's why we're going to focus today on looking at just doing some conversions from the base units using milli and kili prefixes, and then in the next video we'll take a look at all of the other prefixes once we're kind of comfortable with just the basic conversions and how to use the factor label method. And in the next video we'll take a look at all of the other prefixes and do some of the more potentially challenging conversions within the metric system. So when you're looking at milli just means 1,000 times smaller. So if you have a gram or you have 1,000 milligrams, that's the same thing as having 1 gram because it's 1/1000th the size. And kilo is 1,000 times bigger. So if you have 1 kilogram, that means you have 1,000 grams. And we could do the same thing with length and volume. So if we take a look at length, if I have 1,000 millimeters, that's 1,000 times smaller than a meter. A millimeter is 1,000 times smaller than a meter, so you need 1,000 of them to equal 1 meter. And then if you're going to look at a kilometer, kilometer is 1,000 times larger than a meter. So if I have 1 kilometer, that means I have 1,000 meters. Kilometers is what they tend to use to measure. It's almost like equivalent to miles. It's not the same length as a mile, but it's kind of in that same range. So, um, if you want to just kind of think of how big a kilometer is, think of it as being about the size of a mile. It's not the same as a mile, but it's kind of in that range. And then if we do the same thing for liters, again, it's the same prefixes. We're just doing it with either the grams, the meter, or the liter. If you have 1,000 milliliters, that's the same thing as having 1 liter. Because milli is smaller, so you need 1,000 of the smaller units to equal the 1 large unit. And then if you have 1 kiloliter, kilo is 1,000 times bigger, so if you have 1 kiloliter, that means that is equivalent to 1,000 liters. So for all of these, you can see that it's a 1,000 to 1 ratio. It's either getting 1,000 times larger, the kilometers 1,000 times larger than the base unit, and the uh, milli is 1,000 times smaller than the base unit. So it's always going to be a 1,000 to 1 ratio. And we'll see how we can use that when we're working with the factor label method. The biggest problem that students tend to have when they're converting using the factor label method or any kind of method within the metric system is they would know that it's a ratio of 1,000 to 1, but they don't know, am I supposed to multiply by 1,000 or am I supposed to divide by 1,000? Well, if you use the factor label method correctly, it will kind of automatically set the problem up so that you always multiply and always divide correctly. So as long as you know that kilo is bigger and milli is smaller than the base unit, if you just that's the only thing you really need to memorize, kilo is bigger and milli is smaller, then you'll never kind of mix up when to multiply or when to divide when you're trying to convert in the metric system. So let's take a look at this factor label method and take a look at doing some basic conversions in the metric system, um, so that we can go from one of the base units, either the meter, the liter, or the gram, and then convert to millis or kilos. Um, so I have 3 sample problems here, and these are relatively simple problems. And the reason these are considered simple is they're really only one step because you're starting with the base unit, either a meter or a gram, or you're ending with the base unit. Here you're ending with liters. And then you only have one non-base unit involved in the problem. Here it's a kilometer, here it's a milligram, and here it's a milliliter. So we do one problem where it's length, one problem where it's math, and one problem mass, and one problem where it's volume. But they all solve the same way. And it's all going to be 1,000 to 1 ratio for all of these. But these are relatively simple because you're always starting or ending with the base unit. And like I said, the next video will be a little bit more complex, and we'll take a look at maybe you're not starting with base units and you're not ending with base units. So that it gets a little bit more difficult then. But if you understand the basics of how the factor label system works, those problems really won't be any more difficult to solve than these here. So the factor label method is a way of setting up a problem so that the units that you do not want cancel out, and the units that you're trying to solve for are the only ones that are uncanceled out. And it also lets you know when you're supposed to multiply and when you're supposed to divide. So anytime that you have a word problem, and this is another situation where I've found over the years that students tend to struggle in chemistry, is if they have a word problem, they just don't know how to set it up. Now, these are extremely simple word problems in that they're only one sentence each, and there's very small amounts of information in them. But eventually, we're going to get into word problems that are 5, 6 sentences long, and there's maybe 6 or 7 different numbers or values in there, and some of the values you do need to use, some of the values you don't need to use. And students tend to get very confused if I don't even know where to start. So, going through the factor label system from the beginning and making sure you understand this process, it will make it much easier when you get to the more complex problems. I always have students say, "Hey, I learned in high school for the metric system, I just moved the decimal point. So if I'm starting at 1.0, I'll just move the decimal point 6 places this way or 6 places that way." And they say, "Well, can I just do that?" And I begrudgingly say, well, if you want to, you can, because there's multiple ways to do a math problem. I don't care how you get to the right answer as long as you get to the right answer. But I always tell them that, eventually in chemistry, you're going to have problems where you have to move the decimal place 15 spots in one direction and then 8 spots in the other direction and then divide by 10 and then multiply by 20 and then move the decimal place another 6 spots. And you're going to get confused. You can't just keep doing all of that in your head. And inevitably, I always have a couple of students that think, oh, no, I can do it. I'll be fine. And then within a month into the class, they're failing. They don't know how to do any of the material. They didn't learn the factor label method. And a lot of them end up having to relearn the material from the beginning or drop out. So, can you get by doing these conversions without using the factor label method? Absolutely. But it's way easier if you do learn it, and it can be applied to all different fields of science. So, let's kind of get into how to do this. So, the first thing that you want to do is when you're looking at any type of word problem is what are you being given that you're starting with? Well, you're starting with 3 meters here. And what are you being asked to find? You're being asked to find kilometers. So, what you're starting with, you want to write that out on the left hand side. So, we have 3 meters. That's what we're starting with. And what you're looking for or want to solve for, write that out on the right hand side, kilometers. And this will force you to kind of work from left to right, which is kind of the same way that we naturally read. So that'll kind of be helpful so that you're not trying to work backwards or anything. And then the next thing that I always tell students to do is to where they wrote the number and unit that they started with to draw a line there, right at the level of it, and then put 2 big parentheses here. Never forget to write your units in. I always have students that'll just write 3 and then they'll just leave the units out and say, well, I'll just remember what they are. Always write units in. Never leave units out because, like I said, eventually we're going to be doing problems that have 8 and 10 steps in them. And if you leave the units out, you're going to have no idea what the unit is in the end of the problem. So we're starting with meters. We have our sign here. This drawing here, this parentheses with the lines, this is our conversion factor. And what a conversion factor is it just relates the two units, meter and kilometer. How are they related to each other? Well, we saw in the previous slide that they're related to each other by a factor of 1,000. If we had a conversion factor and we were converting between quarters and dollars, the conversion factor would be 4 to 1 because there's 4 quarters for every $1. But in this case, it's 1,000 to 1. You say, well, I don't know where the 1,000 goes. Does it go on top and does the 1 go on the bottom? Don't worry about any of that yet. Students tend to try to write numbers in here too fast. Don't write the numbers in. Put the units in first. You always want to have the unit that you want to have cancel out. And the unit that you want to have cancel out is the unit you're starting with because you want to get rid of the meters and turn it into kilometers. You always write that unit so that they're diagonal to each other. You have meters up here, and then write the meter diagonally down there. That'll have them cancel out. The unit that you want to end up with, kilometers, right up at the top. So now we have our units in place, and meters will cancel out with meters, and your answer is going to be left in kilometers. So we know that our units are going to be correct. Now all you have to do is look at these two units and decide which of these units is the big one. Which one is bigger than the other one? Well, kilometers is the big one. Kilo is 1,000 times bigger than a meter, so it's the big one. If it's the big one, put a 1. The smaller unit, meters, that's the one that gets the 1,000. Okay, so the smaller unit gets the large number, the big one, the big unit gets the 1. So it's 1,000 to 1 relationship. So now we have our units set up so that they cancel out. We have our 1,000 and our 1 correctly set up. And now what you do in the factor label method is you just multiply across and then you divide up in that order. So the first thing that we're going to do is we're going to take 3 times 1. 3 times 1 is 3. And then we're going to divide 3 by 1,000. And that's going to give us 0.003. So 3 times 1 and then divide it by 1,000. And if you need a go ahead, use a calculator for it. It's not like you have to do this in your head. So 3 times 1 gives you 3. And then take 3 and divide it by 1,000 gives you 0.003. So 3 meters is equal to 0.003 kilometers. That is the way to do the factor label method. And I know someone's sitting there saying right now, I could have just moved the decimal place 1, 2, 3 spots and gotten that in a tenth the amount of time. Sure, you could have. But please remember, this is purposely a very simple, basic problem. Eventually, they're going to get much more complex than this, and you're not just going to be able to move that arrow in your head. So yes, it does take you 20 seconds longer to solve it if you write everything out, you put all the units in, but you'll thank yourself later if you learn this method, because it will allow you to do much more complex problems that we will eventually get to, and not lose track of where the decimal place goes or what units you ended up with or started with. So let's take a look at, so this one converted from meters to kilometers. The second problem deals with grams. So the first one dealt with length. The second one is going to deal with mass. So again, we'll do the same thing. We'll start off by writing on the left-hand side what we're starting with. What units are we starting with? So it says here, you have 2.2 grams. That means that's what you're starting with. How many milligrams? That's what you want to get to. So what you're starting with, you put on the left-hand side, 2.2 grams. This will force us to naturally work left to right. What you want to get to, you put on the right-hand side, milligrams. Okay, and then the second step is draw a little line right after what you're starting with. Put a parentheses and a parentheses. That's where your conversion factor is going to go. Before we even worry about, well, where does the 1 go, or where does the 1,000 go, or what is the conversion factor between grams and milligrams, we set it up so that the grams and grams are diagonal to each other so that they will cancel out. And then the milligrams, which is what you want to get to, that'll go on the top. Now we need to know, how is a gram and a milligram related to each other? Well, we saw on the previous slide that milli is 1,000 times smaller. So as long as you know that the relationship is 1,000 to 1, you're halfway there. The last part is, well, where does the 1,000 go and where does the 1 go? Again, you have to ask yourself, of these two units, which of them is the big one? Well, milligram is really small. It's 1,000th of a gram. Compared to a milligram, the gram is the big one. So put that as the 1. Then the milligram, you need 1,000 of those milligrams to equal 1 gram. So now we have our units set up so that they'll cancel out, and we have our numbers set up so that we know what to divide by and what to multiply by. So grams and grams are diagonal each other, so they will cancel out. And then you just need to remember, you multiply across and then you divide up. It's going to do the exact same thing every time. All of these problems are set up the same way. So if we take 2.2 and we multiply by 1,000, we get 2,200. And then if we divide that by 1, 2,200 divided by 1 is still 2,200. So we get 2,200. And the unit that we get on that is milligrams. So 2.2 milligrams is equal to 2,200 milligrams. 2.2 grams is equal to 2,200 milligrams. Okay, so that was the second problem where we were looking at a mass and converting from a base unit to a either the kilo or milli unit. So it was either multiplying or dividing by 1,000. Now the last one, we're going to start with either the milli or killi and convert it back into a base unit, which it really works the exact same way. You're not really switching too much of anything. As long as you understand the factor label method, it won't be a problem at all if you're starting with the base unit or starting with the non-base unit. So for this one, we're going to be doing a volume problem because we're working with liters here, and we're starting with 750 milliliters. That's what we're starting with, so that's what I write on the left-hand side. And what we want to try to get to is liters, so I put that on the right-hand side over here, liters. I then draw a line right after my milliliter, and I put my parentheses in. Again, that's going to be my conversion factor. I put milliliters so that it's diagonal, so that the milliliters will cancel out. And then I put the liters on top because that's what I'm going to end up with. Now we need to know, well, what is the relationship between liter and milliliter? And again, for this video, to keep it simple, I just have them as thousands of a relationship. So there's 1,000 milliliters for every 1 liter. Well, where does the 1,000 go? Do you put it on the top or on the bottom? Well, again, you just ask, which of those two units is the big one? Which one's bigger? Is a milliliter bigger than a liter? No, a milliliter is 1/1000th the size of a liter. So the liter is the big one. Since it's the big one, that's where the one goes. The milli means it's 1,000, so you need 1,000 milliliters to equal 1 liter. Now we've got our problem set up so that the units that we don't want will cancel out. Milliliters cancels out with milliliters. And now you just multiply across and you divide up. It's the same way every time. Once you learn this method, it becomes second nature to you, and it gets very simple. So now we'll take 750 milliliters times 1, and then which is 750, and then we'll divide it by 1,000, which will give us 0.75 liters as the answer. Now again, these problems were relatively simplistic because you're always starting with or ending with the base unit, which makes the steps shorter. But we're going to see in the next video how you can use the factor label method to solve problems that are 3, 4, or 5 steps long, and you never lose track of what units you're working with, and you never mistake, well, am I supposed to multiply or am I supposed to divide? Using the factor label method just keeps problems very organized so that you know exactly what you're supposed to do. And it may not look extremely powerful with these relatively short and simple problems, but as we start getting the problems that are 5, 6, and 7 steps long, you're going to be very happy that you know the factor label method so that you can always get the correct answer and that you don't accidentally multiply something when you're supposed to divide it. So in the next video, what we're going to take a look at is we're going to look at the expanded metric chart. So we're going to look at a lot more of the prefixes, and then we're going to do some more conversions. But we're going to be starting with non-base units and going to other non-base units. So it's going to be a lot more complex metric to metric conversions, but you're still going to be using the factor label method. So if you understand how to do this factor label method, you can do the most complex metric to metric conversions and you won't have any problem at all. So that's what we'll take a look at in the next video. And I hope you learned something, and I'll see you next time. Goodbye.